Okay, now we're going to go over number 17. Explain why ionic compounds exhibit a greater colligative effect than covalent compounds, and review how to determine the Van Hoff factor for ionic salts. So, when talking about colligative properties, the whole idea is that the number of particles of solute we have will make those properties happen. So if we have a greater number of independent particles of solute in the solution, we'll have more effect of our colligative properties, and vice versa. If we reduce the total number of our independent particles, then we'll reduce the effect of our colligative properties. So the reason why ionic solutes have a greater colligative effect than covalent compounds is because when ionic particles are in solution, some of them are going to have an opposite charge. If you have NaCl, table salt for example, and you have Na plus and Cl minus, at some random moments during the movement of the molecules in the solution, the negative and the positive ion will kind of come together and have this brief electrostatic attraction, and that in effect will reduce the total number of independent particles because the two oppositely charged molecules will come together and form an ion pair rather than being two separate molecules or particles. So reducing the total number of particles will reduce the effect of colligative properties. Now the Van Hoff factor is a mathematical equation that helps us calculate the ratio of the actual value of colligative properties to the predicted value of colligative properties when we have a non-electrolytic solution. So when we're dealing with a solution that does not have electrolytes in it, then we can calculate pretty easily the effect of colligative properties. But when we do have an ionic solution, when we have an electrolytic solution, that actual value that we predict for the colligative properties will be different. So the Van Hoff factor says, okay, what is this ratio of the actual value to the predicted value if we had a non-electrolytic solution?